Hello everyone, thanks for joining us today. My name is Patrick Hall. I will be the presenter of this session covering Texas Instruments Bluetooth Low Energy Technology and how to get started with it. The CC2541 Mini Development Kit provides a great out-of-box experience, and in the next few slides we will show how to get a Bluetooth low energy solution up and running in a matter of minutes, given that the Bluetooth Low Energy Stack has been downloaded and installed. The CC2541 Mini Development Kit includes a quick start guide describing how to get started with the kit, a pre-programmed CC2541 key fob that has LEDs, buttons, a buzzer, and an accelerometer, and can be powered by an included coin cell battery. The kit also includes a plastic casing for the key fob, a CC2540 USB dongle pre-programmed with network processor firmware. In the demonstration, the dongle will be used together with our powerful PC application, B-Tool. Finally, the kit also includes a CC debugger and cables that can be used to reprogram and debug the key fob or the USB dongle. To use B-Tool with the USB dongle driver must be installed. Connect the USB dongle to the computer. If prompted for a driver, you can find it in the Stack Install directory as shown on the slide. If not prompted, manually find the USB dongle in Windows Device Manager and update the driver. Start B-Tool and select the COM port associated with the USB dongle, keeping the other settings unchanged. There are two possible ways to power the key fob, either with the CR2032 coin cell battery or via the CC debugger. If the key fob is powered from the CC debugger, the coin cell battery must be removed and the jumper must be mounted on the P1 header, which is located next to the LED. When the key fob starts up, the LED will be lit green for 1 second. The key fob will not immediately be connectable. To enable advertising and make the key fob discoverable, press the right button on the key fob once as shown in the slide. This will turn advertisements on, making the device discoverable. While advertising, the LED will be blinking red. After 30 seconds, the device will return to standby mode. The main screen of B-Tool is divided into 3 sections. The Device Information section presents information about the USB dongle and Bluetooth Low Energy devices connected to the USB dongle. The Message Log window shows the log of all serial communication between B-Tool and the USB dongle. This includes the commands used to control the network processor firmware pre-programmed on the dongle and the events received from the dongle. The Device Control window provides an interface to control the network processor and communicate with connected devices. After starting B-Tool, the dongle is automatically set up as a central device. You are now ready to scan for advertising Bluetooth low energy devices. Press scan and make sure your key fob is still advertising. The USB dongle will then scan for advertisers and list all connectable devices in the drop-down menu labeled Slave BDA after this discovery process is complete. Select your key fob while making sure it is still advertising and press Establish. After the connection has been successfully established, the connected device will be displayed in the Device Information section. There are several services and profiles implemented on the key fob. As previously described, the application gets notified by the services when a change has been made to a characteristic, such as the alert level characteristic. The application uses this to implement the profile, such as the proximity profile. In the following example, we will use the TI proprietary simple keys and accelerometer profile via the proprietary services shown on the slide. We will also trigger a buzzer sound via the officially adopted immediate alert service. A note on the upcoming example. Every service, characteristic, property, value, and descriptor is assigned a unique internal address called a handle. The handles associated with this service and characteristic can be obtained by performing service discovery either with btool or BLE device monitor. Pressing a button will make the key fob application internally update the value of the button press characteristic. To allow the key fob to transmit the updated characteristic value without explicitly being asked for it by the central device, we must enable a feature called notifications for that characteristic. The handle to enable button notifications is 48 hexadecimal. This handle accepts a 2-byte value, so we must send the value 1 as 0100 to enable notification on button presses. This is done in the Read/Write tab of btool as shown in the slide. When this is enabled, pressing the left button will let the key fob send 01 and pressing the right button will send 02. This will be displayed in the btool message log window. To sound the buzzer located on the key fob, we use the immediate alert service. For a low pitch sound, write the value of 01 to the alert level characteristic, which is assigned handle 28 hexadecimal as shown in the slide. If you want a high pitched sound instead, write 02. To turn off the alert, press a button or wait 10 seconds for the alert to time out. Alternatively, write the value 00 to the characteristic handle. To use the accelerometer, we use the TI proprietary accelerometer service. We must first enable the accelerometer hardware by writing 0100 to the accelerometer enable characteristic located at handle 34 hexadecimal. This tells the application to power the accelerometer. To enable notifications for the x-axis, write 0100 to characteristic handle 3B hexadecimal. This will enable the key fob to send notifications when the acceleration data changes. In this example, we will only enable notifications for the x-axis. However, enabling the other axes follow the same method and is explained in the Development Kit User's Guide. The source code for the key fob application, as well as many others, are included in the Bluetooth Low Energy software solution. The sample application we just used is called Key Fob Demo. The application can be modified as desired and is a good template for developing your own custom Bluetooth Low Energy application. There are several other sample applications included in the software solution. Most are profile specific, for example, heart rate and glucose. These can be helpful if you are going to implement a specific Bluetooth SIG adopted profile. If you are not going to use a specific Bluetooth SIG adopted profile, or you have not decided yet, a good start is to look at our generic applications which have the prefix Simple BLE. These implement the mandatory GATT and GAP profiles and also some proprietary profiles. Any further information you may need can be found by following these links. The first link will bring you to the Bluetooth Low Energy landing page, where datasheets, kit information, and sample requests can be obtained. The Bluetooth Low Energy Wiki contains more application examples, test reports, and other useful information regarding TI's Bluetooth Low Energy offering. For additional help, visit the TI Bluetooth Low Energy E2E forum for instant support during your development. Last but not least, a direct link to the Sensor Tag product page. Thank you for watching and good luck with your developments.